Have you ever wondered how an airplane works? Imagine yourself holding an ordinary piece of paper. Now turn it into a paper plane and watch it fly. That's aerodynamics in its simplest form, but how does this relate to a real airplane? Airplanes, like your paper plane, rely on the basic principle of lift and gravity. Lift is the force that pushes the airplane up while gravity pulls it down. The wings of an airplane are designed in such a way that they create lift, overcoming gravity and allowing the plane to ascend. But wait, there's more. In fact, there are 4 forces acting on an airplane at any given moment. These are lift and weight, or gravity, as we've already mentioned. And there's also thrust and drag. Thrust propels the airplane forward while drag tries to slow it down. So the plane takes off when the lift generated by the wings overcomes the weight of the plane. Now, let's see how this works in action. So, how does a massive metal bird like an airplane take to the skies, you ask? Well, it's all about the engines and their role in generating thrust. Think of thrust as the force that propels the airplane forward. The engines churn out a tremendous amount of power, pushing the plane down the runway. Meanwhile, inside the cockpit, the pilot is revving up the engines, increasing the thrust. The airplane starts to speed up, barreling down the runway with increasing velocity. But thrust alone isn't enough. We need lift too, and that's where the flaps come into play. These flaps, located on the wings, can be adjusted to increase the lift during takeoff. As the plane accelerates, the flaps create an upward force greater than the weight of the plane, causing it to rise from the ground. And with the right speed and lift, the airplane takes off into the sky. But once it's up there, how does it stay on course? That's a story for another scene. Navigating through the vast open sky is no small feat. Steering an airplane is mainly achieved through the use of the rudder and ailerons. The rudder, located on the tail, helps the plane turn left or right, while the ailerons, found on the wings, allow for the aircraft to roll and bank into turns. But how does the pilot know where to go? Well, that's where the plane's compass and global positioning system, or GPS, come into play. These tools help pilots determine their direction and position relative to their destination. And then there's the autopilot system, a technological marvel that can control the plane's direction, altitude, and speed, relieving the pilots during long flights or complex situations. But of course, pilots don't navigate the skies alone. They're in constant communication with air traffic control, who provide guidance and ensure safe distances between aircraft in busy airspace. With these systems, pilots can navigate the skies with precision, but how do they bring the plane back to Earth safely? Landing an airplane is perhaps the most delicate part of a flight. As the pilot prepares for this crucial phase, the thrust of the engines is reduced to slow the aircraft down. At the same time, flaps on the wings are extended. These flaps increase the drag, or air resistance, which helps the airplane descend at a controlled pace. Now, as the airplane nears the runway, the landing gear is deployed. These sturdy wheels are designed to absorb the impact of landing and provide braking, allowing the plane to slow down and come to a stop. Throughout this process, the control tower plays an integral role. Air traffic controllers coordinate with the pilot, providing vital information about wind conditions and other factors. They ensure the runway is clear and guide the pilot to a safe landing, and that's how an airplane lands, bringing us safely back to Earth. So in just a few minutes, we've taken a journey through the workings of an airplane. We started off with the basics of aerodynamics, understanding the principles of lift and drag that make flight possible. We then experienced the thrill of takeoff, as we explored how the combination of speed and angle allows an airplane to defy gravity and ascend into the skies. We navigated through the complex systems that pilots use to control these marvels of engineering, from the cockpit's array of instruments to the autopilot feature that ensures a smooth and steady flight. We also delved into the intricate process of landing, appreciating the precision required in adjusting speed, altitude, and direction to bring the plane safely back to Earth. It's a fascinating world up there, isn't it? Next time you're soaring through the skies, you'll know just what's happening beneath the wings. Until then, keep your curiosity alive and